Hello students, welcome to EPG Parshala. I am Sumalay Roy from Department of Physics and Astrophysics of University of Delhi. Today we are going to discuss about the module wave-particle duality in Young's double slit experiment and its quantum mechanical interpretation from the paper Quantum Mechanics. The discussion of several phenomena along with the corresponding experimental data studied in the preceding two modules clearly showed conclusively that both electromagnetic radiation and material particles at microscopic level possesses dual nature. That is, radiation behaving as wave can also exhibit a discrete photon character, and similarly, discrete nature of material atomic particle behave as a wave. In this module, we analyze this aspect of duality by revisiting Young's double slit experiment. We shall arrive at an important conclusion that light behaves simultaneously as a wave and as a stream of independent photons. The wave nature, which appears to be an inherent property of photon, enables us to calculate the probability of the manifestation of a photon. The interference pattern is a statistical property of photon. Thus, the classical picture that each particle or a photon has a definite and deterministic position at any instant has to be discarded. From a standpoint of quantum mechanics, the interference pattern would be destroyed if a sufficiently careful attempt is made to determine through which slit each photon was passed. We generalize this picture to introduce a wave function for a quantum mechanical particle in terms of which the probability distribution is defined. The principle of superposition for two wave function is also discussed. The wave function describing the motion of a free particle with definite momentum and energy is introduced, and it is shown how these quantities act as operators on the wave functions. Quantum mechanical viewpoint. From the point of view of classical theory, this assumption is natural since classically each particle or a photon has a deterministic position at each instant of time. At the quantum mechanical or a microscopic level, this picture is to be discarded. A detailed analysis shows that it is impossible to observe the interference pattern and to know at the same time through which slit each photon had passed. From the above experiment, we have also seen that as the photons reach the screen one by one, their impacts gradually build up the interference pattern. That is to say, particular photon, we cannot anticipate where it will strike the screen. We can only say the probability of it striking the screen at a point x is proportional to the modulus of Ex square. So students, let us summarize what we have learned in this module. The duality aspect of photons and quantum particles through Young's double slit experiment. We have learned that it is an inherent property of photon to behave simultaneously as a wave and a particle. We have learned that the classical picture that each particle or a photon has a definite and deterministic position at any instant has to be discarded. We have learned that wave nature enables one to calculate only the probability of a manifestation of photon. We also know the description of a quantum mechanical particle by introducing a wave function in terms of which probability distribution is defined. We have learned the superposition principle of wave functions. We have studied the wave functions of particles having definite energy and momentum. We have learned how energy and momentum act as operators operating on the wave function. Thank you very much.